Okay, good evening. Thank you for inviting me here to present this again. I think this is probably the seventh year. I remember presenting the first time in I think 2009, 2010 when Lila and Cowan did the first the Why and How series. So it's always been fun, at least for me. Just to start, let me preface by saying that the intended level of this is, so I think this type of seminar is mostly intended for two categories of people. So those of you who have had very little exposure to neuroanatomy prior to this, so those of you coming from, I don't know, engineering or physics, etc., other disciplines that really don't teach much or any neuroanatomy. And but also there might be some of you who have been working the last 20 zillion years in a specific subfield in the hippocampus or something, and they want a general refresher of what's going on in the rest of the brain. So in order to satisfy these needs, I'm gonna necessarily cover quite a bit of material, a lot of structure, but necessarily will be pretty superficial. Okay, so hopefully, well, some of you will probably be bored out of their mind, and some of you might be overwhelmed at the end, but hopefully most of you actually have a little bit, might be engaged. Okay, so in the spirit of engagement, so what I'm going to do actually, I'm going to start by showing you a video, and this is the single reason why I get invited all the time, okay, to this seminar, to give these seminars. So this is a brief introduction to the major structure of the brain by an expert, and it's going to be just about 2 minutes. I just ask you to please pay attention, because this guy actually makes a lot of mistakes. So try to note down, if you do note any mistakes, note them down. Then we're going to redo this again one more time at the end of the seminar, and hopefully the number of mistakes you've identified is increased. Okay, I'm going to quiz you at the end. Okay.
And now the art of the day, performed by the play.
Yes. Medial cortex frontal lobe. Hippocampus neural node. Right hemisphere. Pons and cortex visual. Sylvian fissure pineal. Left hemisphere. Cerebellum left. Cerebellum right. Synapse hypothalamus. Striatum dendrite. Axon fibers matter brain. Central tegmental pathway. Temporal lobe. White core matter, forebrain skull. Central fissure, cord spinal. Parietal. Diameter. Meningeal vein. Medulla oblongata and lobe limbic. Microelectrodes. The brain. That ought to keep the squirts happy. Yeah.
Alright, so I don't know if you guys have noticed any mistakes. I'll quiz you at the end, okay? And hopefully actually you'll show me that you learned a little more. Okay, so let me start actually by giving you some information about some potentially helpful resources, some books and other resources that you can refer to. So I enjoy quite a bit the Neuroanatomy Through Clinical Cases by Hal Blumenfeld, just as much as anybody could enjoy a neuroanatomy book, but it's a recommended reading. And then there are several digital applications. There is the Digital Anatomist is an excellent website, and actually took a lot of models and pictures from that website. There are very nice 3D models that really give you a good idea of where the different structures are located with respect to each other. So I encourage you to look at that. And then there is Silvius and iSurf, and they also they come with a iPhone app, and as a member, as a faculty member in Martinos Center, I think I'm legally bounded to encourage you to look at the iSurf particularly. But aside from jokes, it's actually a nice app. You can actually point a different structure, and it's going to tell you, hey, this is the thalamus, this is an insula, etc., etc. And also, as always, I like to thank Emma Durden, with whom I was TAing when I was up in McGill for neuroanatomy courses, and she actually has. So let's start by giving you some introduction to the orientation. Okay, so first of all, so this is the brain. Okay, so you're seeing here this. I actually draw these eyes so that you can actually have a better idea of the orientation. So this is the lateral side of the right hemisphere. Here you can see the cerebellum back here. Down here starts in a little bit of brainstem. Okay, and here this is the same brain, but looked from above, so from the top down. So you can imagine it's as if this gentleman, let's assume it's a gentleman, is lying on a table, lying on a bed, and with the head towards you, and the feet are basically on the other side of the screen, okay, and the eyes will be up here. So two terms that I think you should be familiar with is dorsal and ventral, and I'll present you with a caveat very soon, but for most of the brains, certainly for the hemispheres, dorsal means towards the top, and ventral means towards the bottom, okay? And rostral means towards the front, and caudal means towards the back, okay? And if you actually look at this, so we're looking now at the dorsal aspect of the hemispheres, okay, from the top, and this is again rostral towards the front, towards the eyes, and caudal is towards the back. Also, you can see there are two hemispheres, and they are separated by space. This is called the interhemispheric fissure. We'll get back to this, but if you're very close to the closer you get to the interhemispheric fissure to the midline, the more medial you are. So medial is another term that you need to have knowledge of. And then if you move away, in fact, you're more lateral. And so just to give an example of how these terms are used, so this part of this is the frontal lobe. Again, we'll get back to it in a few slides. And this specific part is called the prefrontal cortex. And the lateral, we are here in the lateral prefrontal cortex, and it's typically divided into two big chunks, okay? One is more dorsal, and one is more ventral. So this part here will be the ventrolateral prefrontal cortex, and down and up here would be the dorsolateral prefrontal cortex. And actually, if you actually look at the medial side of the wall of the medial side of the brain, so it's so-called the medial wall, there's also a medial prefrontal cortex, also divided into dorsomedial and ventromedial prefrontal cortex. So this just gives you an idea of how these terms are used. I was telling you that I was going to give you a caveat. So I was telling you before that dorsal means towards basically up, and ventral means towards down. This is true only at a certain point, okay? So below the brain, so at the level of the brainstem and below, things change a little bit, and it's a little bit complicated. So essentially, the reason for this is that this terminology was created having in mind animals such as this lizard, which have linear organization of the central nervous system, okay? So in this case, rostrum always means towards the front, and caudal means always towards the back, okay? So you have to imagine, if you think about your arm, okay, and you put your fist like this, okay, and your fist is your brain, you can imagine that the part of your arm that has the hairy skin is always dorsal, okay, and the part of your arm that has the glabrous skin is always ventral. And it's always true that, you know, the ventral is always towards the back, right? Sorry, towards up, okay? In humans have evolved to have an upright posture, and in order for to accommodate for this, the evolution actually created a bend into the nervous system, right? So there is this bend, and this bend happens to be here, just above the midbrain. It's called this midbrain diencephalic junction. And so if you actually look at your arm now bent, it's always true that, you know, the hairy part of your arm is your dorsal aspect of the nervous system, but you can see how here dorsal is superior, but here dorsal it's actually towards the back. So it's a little bit confusing, and again, I don't expect you to kind of get this immediately necessarily, but at least I want you to warn you that, you know, this terminology can be a little bit complicated depending on where you are, can change a little bit the meaning, okay? After confusing you, I'm gonna talk to you about some other terminology. Hopefully it will be even more straightforward. So a lot of us work with tomographic images, with PET, with MR, etc. And this data typically are acquired in slices. So it's important to actually understand what the name of the different planes are. So one of these planes is the horizontal plane. So you have to essentially imagine a plane that is parallel to the horizon, okay? So it separates essentially would split your eye from your nose, essentially, just to give an idea, okay? And then there's a coronal plane, which is parallel to the way you would put your tiara-like crown for the princesses in the in the room. I have 2 princesses at home, so I know about it. And then sagittal. For sagittal, you have to think about the bow of an archer. So basically, it's a plane that would split especially your head, you're facing to. Okay. And so this is what an MRI would look like in this plane. So this is an horizontal, also called axial or transverse. Everything has multiple names for some reason. This is a coronal view. So in this case, let's say this gentleman is looking at you, and this would be a sagittal slide. So when the sagittal plane is cut the brain right in the middle, it's called a mid-sagittal section. When it's a little bit off the center, it's called parasagittal. So this is something else you might encounter. Okay. Are there any questions about this at this point? All right, so let's go directly to the major subdivision of the brain. So there are different ways in which people subdivide the brain, but this is one of those. So right here you can see the telencephalon, which comprises the cerebral hemispheres, including the cortex and the white matter containing it under it, and then subcortical structures. Okay, and we'll get to it. Okay, we'll actually go a little bit more into details. Below it is the diencephalon, which includes the thalamus and hypothalamus and other associated structure. And some people consider, group together the diencephalon and telencephalon, basically you see in red and yellow, together as the forebrain or cerebrum. Okay, just at the bottom of the cerebrum, just below the cerebrum, you find the brainstem. Okay, and there are different structures. This would be where the midbrain is located. This is the pons, and this is medulla oblongata. But again, we'll get to it. Okay, I just wanted to quickly introduce with the name. And just behind it, and I should say dorsal to the brainstem, you actually find the cerebellum. And the cerebellum and part of the brainstem is also referred to as the hindbrain. Okay, so other people would just say, the brain. There are 3 major subdivision. One is the forebrain, one is the midbrain, and then the other one is the hindbrain. Okay, so let's go. So we're going to move from the caudal, from more caudal structure to more rostral structure. Okay, so we're going to start first with the brainstem. So in this case, the gentleman is lying on a bed, and the feet are towards you, and the head is towards the screen, and you can see this is where the eyes would be located. I know this is a bit creepy, but I don't know. I find it kind of funny. So the brainstem is contiguous to the spinal cord. So in order for the brain to be extracted, they actually had to sever to the cut section the spinal cord just here. Okay, and just above the spinal cord, it's the medulla oblongata. Okay, this is the red structure here, and I'm going to try to give you some tips, some cues to allow you to identify all the different regions. Okay, so I'm not going to so much talk about function in this seminar, but most about really purely anatomy, to give you some hints of how to identify, for instance, if you're looking at an MRI, something that seems to be potentially helpful for you guys. So 2 structures that make you immediately know that you are in the medulla oblongata are these 2. They look like almost two electric cables, if you agree with me. So essentially bundles of fibers, okay, running from the top of the brain down to the rest of your body, and these are called the pyramids or pyramidal tracts. This is actually something I say every year, and I still have no answer. I never understood why they're called pyramids. So if anybody can illuminate on that, please let me know. Okay, and if this is published on YouTube, hopefully somebody can write to me from somewhere in the world. Okay, so laterally, with respect to the pyramids, are 2 little bumps. Okay, you see one here and one here. These are the inferior olives. Makes a little sense. They kind of look like olives, so I guess the neuroanatomies were more right here. So when you see the pyramids and the olives, you know that that's the medulla. Okay, then we're going to move above, more rostrally, okay, more superiorly, and in this case we're gonna find this big gigantic belly. This is the pons. It's very easy to see. Actually, this is not a great picture. You're gonna be able to appreciate it even more with other orientation, but it's a big belly, okay. It's almost like a ball, okay, up here, and on top of it, partially hidden by, you know, this part is the medial aspect of the temporal lobe, but you can kind of see it in blue, is the midbrain. And so the distinctive feature of the midbrain in this case is these two bigger, these gigantic bundles of fibers. It looks like they are two big ponytails containing fibers, and in fact these fibers go down the caudally, and some of those terminate in the pons, but some of those are actually the ones that end up being part of the pyramidal tract, okay. So it's as if it was like a highway with many routes, and then some of the routes actually stop here, and then the rest keep on going down, okay. So let me see. Okay, and this is essentially, I told you all about this. You can see the pyramids, the inferior-olives. You start seeing also some additional structural other details. These are the cranial nerves. We are not going to go into the detail for now. And then the pons, midbrain, and you can see the cerebral peduncles. Yes, I think I covered everything. And of course, behind the brainstem, you find the cerebellum. Now, I know. Okay. So now we ask this gentleman to, he was lying down, now we ask the gentleman to actually sit up on his bed and look towards you, okay? And so you can see again, you can even more appreciate again the pyramidal tracts, the olives, you can clearly see here the pons, and now some part of the, actually most of the brain has been removed here, so you can even more, even better appreciate those cerebral peduncles, okay? Those are the structure, the two big ponytails I was telling you before, okay? So now we are going to ask the gentleman to turn on the other side, so look towards the screen, so you're seeing the back of the head, and the cerebellum is being removed, okay? Remember that the cerebellum is just behind, it's dorsal with respect to the brainstem, so if it wasn't removed, you'll probably see mostly the cerebellum. So this has been removed, and in order for it to be removed, some bundles of fiber connected the cerebellum to the brainstem were had to be cut, right? And these bundles of fibers are the so-called cerebellar peduncles. So before I was telling you about the cerebral peduncles, right? So these are here, the cerebral peduncles. So not to be confused with the cerebellar peduncles. So the cerebellar peduncles are bundles of fibers that connect the cerebellum to the brainstem. Okay, they go in this direction. Okay, and there are three: an inferior cerebellar peduncle. Well, there's one on each side. Okay, and then the middle cerebellar peduncles, one here, and then the superior. Okay, so the middle one is the biggest one, and when you see it, you know they are at the level of the pons. Okay. If you go rostrally, you start seeing these four bumps here, and these are the superior and inferior colliculi. There is one superior and one inferior colliculum on each side, and when you see those, you know that you're in the midbrain. Okay, so these are more giveaways for the midbrain. In this case, I'm showing you a sagittal image, specifically a mid-sagittal slice, and again, you see the medulla oblongata here, and then the pons and the midbrain. There is not a lot of details here. I think that will make your life easier to identify the different structure. But I want to point out that there is this little channel here. Okay, you see it's a little groove. This is the so-called cerebral aqueduct, also called Sylvian aqueduct, and we'll get to the ventricular system in the next few slides. But when you see this little channel here, you know that you're in the midbrain. So this is another feature that allows you to understand that you're in the midbrain. And of course, behind there is the cerebellum. So when you're looking at, let's say, an MRI, this is an axial image, an axial slice. You're pretty low, and you say, okay, where am I here? Which part of the brain is this? So this looks like the cerebellum, for instance, right? So it's on the back of the head. It's like pretty big, and you see all this, looks like striations, or anyway. So this is, yeah, definitely, I would say cerebellum. In front there is something. Probably is the brainstem, because I know that, you know, just in front, just ventral to the cerebellum, there is the brainstem. But at which level? So if you actually look at this image a little closely, you see these two ventral bumps here, and this is not super clear, but there are two bumps on the side. So this looks to me like the pyramidal tracts and the inferior olives. So I think I am at the level of the medulla. Okay. Now I'm going to move a little higher up, and I see again the cerebellum, and I do see a large belly here. Okay. And this large belly is connected by this large bundle of fibers. So this is the middle cerebellar peduncle, and this is the pons. Okay, so when you see the belly, it's easy, I think. And then, okay, so this is easy. Okay, so how do you identify? Well, how do you know when you are in the midbrain? Well, when you see Mickey, right? So these are the cerebral peduncles that form the ears, and then you have the nose. Remember, I was telling you that there is the cerebral aqueduct, the Sylvian aqueduct. It's a little tiny channel. Okay, this is what it looks like in a section. Okay, so the nose is the aqueduct, and actually it's not appearing in this image, but actually there are even eyes. So it's something called the red nucleus on both sides. So it's really easy to identify the brainstem this way. So the midbrain for this way. Okay, are there any questions about this? Okay. Am I going too fast? Am I going too slow? Okay, good. Okay, great. All right, so now we're moving again from going this direction, caudorostrally, and above the brainstem, if you remember, the next section is the diencephalon. The diencephalon is made of mostly the thalamus and the hypothalamus. So the thalamus is like an egg-shaped structure. There is one in each hemisphere, okay, and it's pretty easy to identify, not so much from this image, but you'll see it's a pretty prominent feature. And just below and a little bit ventrally and a little bit rostrally to it, there's the hypothalamus, okay, and the two are separated by a very tiny sulcus called the hypothalamic sulcus. Now, I was saying the thalamus is pretty easy to identify, especially in MRI. The hypothalamus I've always found a little bit more tricky, but there is a trick. And for those of you who are fan of, food-related metaphors for neuroanatomy, you can use the ice cream tip. I learned this when I was at Medial. So the scoop is the thalamus. And you can see this triangular structure below it. This is the cone, and the cone is the hypothalamus. So I'm pretty sure you'll not forget about it anymore. So now we're looking again at a ventral view of the brain. So again, this gentleman is lying again on bed and is looking up, okay, and the feet are towards you, and the head is towards the screen. Again, from here you'll be able to recognize the brainstem. You're going above the brainstem. You can probably remember these are the cerebral peduncles. Okay, and what are the structures here? So these structures here are the mammillary bodies. Okay, there's two bumps here. Okay, and then another very prominent feature is this big X. You cannot miss it. This X is actually the optic chiasm, which is made of fiber coming from the optic nerves. Some of those cross to go on the other hemispheres, and some of the others actually continue staying in the same hemisphere. But bottom line, they form this X, so it's very easy to recognize, okay? And in between the optic chiasm and the mammillary body, there is, and it's not super easy here to see, is the so-called infundibulum. Pretty sure I'm not pronouncing this right. Of the pituitary gland is the pituitary stalk. So essentially, it's that structure from which the pituitary gland hangs, okay? And I'll show you a little bit better. So you can actually see this again. It's a mid-sagittal section. You can see here the mammillary body. Here you only see a section of that X, the optic chiasm, and this is the pituitary stalk or infundibulum, and this is where essentially the pituitary gland would be. Okay. The reason I'm showing you this is that these are also landmarks that can help you figure out, orient you a little bit at the level of the diencephalon to tell you where you are. Because if you stick a electrode anywhere between the mammillary body and the optic chiasm, you see, stick it here or here, you are at the level of the hypothalamus. So I use these to know, to orient myself to know that I am at the level of the hypothalamus, okay? Because the hypothalamus lies just dorsal to these structures. Okay, so now again, this is the picture in which the gentleman is looking in the other direction towards the wall. So you're seeing the back, and the cerebellum has been removed. Remember, these are the superior and inferior colliculi, and so this means that you are in the midbrain. And on top of it, you see these two gigantic egg-shaped structures, and this is the thalamus. It's very prominent. Okay, and these are two coronal slices, and to show you what the thalamus looks like, you can see it's pretty at the center of the brain. There are two egg-shaped structures, and again they're separated by a space here, and I'll talk to you about it. And then if you actually move a little bit more from this direction to this direction, so I'll go a little bit more towards the front, you start seeing that you no longer see these two egg-shaped structure, but you see this structure, and this is the hypothalamus, okay? But you still see some space in between the two half of the hypothalamus. So this space in between the two half of the hypothalamus and the two thalami is one of the ventricles of the brain. In particular, it's the third ventricle. And I think that this actually it's a good time for me to introduce a little bit to the ventricular system. And it's not the most exciting part of the brain, because cavities in your brain probably are not the sexiest part of your brain. But again, it gives you, first of all, it's very important to know, because it contains cerebrospinal fluid, which protects your brain and does also other nice things for you. But also, again, the ventricular system actually provides a set of landmarks that allow you to distinguish different structures, or at least helps me orient the brain. Okay. So there are four main ventricles. These are the lateral ventricles that are like skewed C shapes, you see? And these are located in the hemispheres. Then there is one third ventricle. So there is one lateral ventricle in each hemisphere, okay? Then there is one third ventricle, as I was telling you before, between the two thalami, and here would be between the two half of the hypothalamus. This looks like a goose. I don't know, do you guys see a goose or just yeah? So basically, where the head of the goose is between the two thalami, and where the beak of the goose is between the two half of the hypothalamus. I'm pretty sure some neuroanatomist is screaming at me right now, but it helps me. So. And then there is the fourth ventricle. The fourth ventricle is actually, you should be able to see it very nicely here, is located between the brainstem and the cerebellum, okay? And the third and the fourth ventricle are connected by the cerebral aqueduct. So this is where your midbrain is, okay? So again, if you look at bigger, so fourth ventricle between brainstem and cerebellum, and then you have the cerebral aqueduct in the midbrain, and then the third ventricle will actually be, so this is the thalamus in purple, and in yellow is the hypothalamus. The third ventricle is located inside, so in between the two thalami, or the two halves of the hypothalamus. And then you have the lateral ventricles that are located buried inside, deep into the hemisphere. So you're seeing here this one just because just for illustrative purposes, the whole one half of the brain is being removed essentially. And this is again, a mid-sagittal section, and you can see all the different, fourth cerebral aqueduct, and this is where the third ventricle would be. And when you see the third ventricle, you know that you're at the level of the thalamus and hypothalamus. All right. Are there any questions? So, and then there is the cerebral hemispheres. So the cerebral hemispheres are there are two in most people. They are interconnected by a number of fibers. In particular, the corpus callosum, which is a very big and very prominent feature. I mean, you cannot really miss it. It looks like a saddle. Or at least like an inverted saddle. But in addition to the corpus callosum, you also have the anterior commissure, the posterior commissure, and in some individuals, something is called the massa intermedia or interthalamic adhesion. I can't remember if 33% of people do not have the massa intermedia or do have, but not everybody has it. This is the point. So I want to give you some tips about identifying the anterior and posterior commissure, because especially for those of you who do brain imaging, often we try to orient the planes the slice of acquisition parallel to the so-called ACPC line, and the ACPC line stands for the line passing from connecting the posterior commissure and anterior commissure. Okay, so how do you identify the anterior commissure? So it's actually not so difficult. So you see, this is the corpus callosum. It's easy to identify. Okay, you see there is this little bundle of fiber that looks like it's jetting out of the corpus callosum. In fact, it's a very different structure because the corpus callosum is actually connected to hemispheres. This thing that I'm showing you is the fornix, and the fornix actually connects two structures within the same hemispheres, and particularly the hippocampus to the mammillary bodies. Oops. So, but in a mid-sagittal section, it looks like it's coming out of this the corpus callosum. Okay, so in order to meet, its destination is here, the mammillary body. In order to get there, it has to dive vertically, and when it dives vertically, and at that point it's called the columns of the fornix. When it dives vertically, just in front of it, that's where you find the anterior commissure. Okay? So just look for the fornix. When it becomes vertical, just in front of it, you'll see a little circle, and this is the section of the anterior commissure. The posterior commissure, it's probably a little more subtle to identify, but look at your midbrain. Midbrain, I see it here because I see the channel here, so the little cerebral aqueduct. Just on top of the midbrain, you see a little curl, okay? This curl is the posterior commissure. So once you identify the midbrain and this little curl, you identify the posterior commissure, okay? So now you're all able to position your MR slices perfectly. So, so we talked about two hemispheres connected. In each hemisphere, there's the cortex, there's the white matter beneath it, and then there are several subcortical structures, and we'll deal with them. And the cortex is made of gyri and sulci. So the gyri are the hills, and the sulci are the valleys. So especially humans, we needed to develop a strategy to pack in our brain an expanding cerebral cortex, right? And one option was to create a gigantic head, but I guess that would not have agreed with upright posture. So the other option is actually to kind of create a system. Oops, sorry. Okay, of gyri and sulci. Okay, and sometimes you hear the word fissure. Oh, did I do something wrong? The word fissure is often interchangeably used with sulcus, but I believe that fissure is more like a very deep sulcus. Okay, so just remember that. So, for instance, the lateral fissure, the central fissure, etc. Then there are four undisputed lobes. There is the frontal, parietal, temporal, occipital lobe, and we'll show you this in the next slide. And some people add also to this list also a limbic lobe, and the insula is a separate lobe. I don't think everybody agrees with these two as being actual lobes, but some people call it this way. And these are the four, let's say, undisputed lobes. So again, this is the brain. Hopefully you recognize it this time. So this is the frontal lobe on the front of your brain. Of course, it's actually one of probably the largest one actually. And then behind it is the parietal lobe. Towards the back of your head is the occipital lobe, and then on the side of your head, closer to your ears, is the temporal lobe. So how do you identify, the borders between the different lobes? Okay, so there are a few landmarks, and some of these are actually pretty sketchy, if you ask me. So, the central sulcus, and I'll tell you how to identify. I'll give you a cue about how to identify, especially on MRI. So, central sulcus or central fissure, also called Rolandic fissure or Rolandic sulcus. Everything has at least 4 names. It's one one of the important ones that you need to know, and it's the one that basically defines the location of the frontal lobe. So in front of it, okay, will be the frontal lobe. Then another important fissure is the lateral or Sylvian fissure, okay, or lateral sulcus, or Sylvian sulcus, and below it is the temporal lobe, okay. Now for the occipital lobe, and in general for the border between occipital, parietal, and temporal, things are a little bit undefined. Okay, so because technically, in order for you to determine the limits of occipital lobe, you have to identify this. So this is the parieto-occipital fissure. You don't really see the parieto-occipital fissure on the lateral side. It's actually quite deep fissure in the medial aspect of the brain, but you can start seeing a little bit emerging or peeking out here. Okay, so this is one landmark here, and then few centimeters away from the occipital pole, okay, this would be where the occipital pole would be, there is a little indentation. This is the pre-occipital notch. So if you draw an imaginary line between the pre-occipital notch and the parieto-occipital fissure, this is how the occipital lobe is defined. Okay, so again, I don't, this is not really a satisfying definition in my mind, but that's how people use. This is from Grey's Anatomy. This is my usual joke. People usually thank you. Okay, so there is a lot of variability, as you can imagine, across brains. So what I usually suggest to do is actually to familiarize yourself with a model, like an idealized model of the brain that can show you where the main sulci are, and then you move from there, and you can actually start recognizing them in real brains. So again, this is a lateral aspect of the brain. It's a left hemisphere. This is where you would find your central sulcus, and so all of this would be frontal, and then behind here you find the parietal. This is the lateral or sylvian fissure. So below it is the temporal lobe, and in the back here somehow is the occipital lobe. Okay, so once you identify the central sulcus, actually several things actually are identified as a consequence to that. So there is a gyrus just in front of it, and that's the pre-central gyrus, and just behind it is the post-central gyrus. Okay, these are also functionally interesting lobes because the pre-central gyrus is contains the primary motor cortex, and the post-central gyrus contains the primary somatosensory cortex. To throw in some functional neuroanatomy to this pure gross anatomy seminar. In front of the pre-central gyrus there is the pre-central sulcus, okay? And then you can see here two major sulci that actually run in a direction. So the central sulcus and also the pre and post-central sulci run medial to lateral, okay, you see? But then this one here and this one here ran in a longitudinal fashion, okay, so rostrocaudally, okay, and these are the superior frontal sulcus and the inferior frontal sulcus. And once I identify this one, you know that this is the superior frontal gyrus. In between the two sulci is the middle frontal gyrus, and just below the inferior frontal sulcus is the inferior frontal gyrus. Okay, and this is the major organization of the frontal cortex, at least laterally. The temporal lobe is actually similarly organized, meaning that there are this superior temporal sulcus, there is also a middle temporal sulcus, and there's also an inferior temporal sulcus which you cannot see from the lateral view of the brain because it's kind of more towards the base. But again, very similar to what you did for what you can do from the frontal lobe. You can identify the different temporal gyri, after you identify the sulci. So the superior temporal sulcus separates the lateral fissure from the superior temporal gyrus. Okay, and then you have the middle temporal gyrus, and then you have the inferior temporal gyrus down here. Okay, now so here this is the parietal lobe. I was telling you just behind the central sulcus there is a post-central gyrus, okay, and behind the post-central gyrus actually there is the so-called posterior parietal cortex, which is divided into two main sections. They're called two main lobules, which is the superior parietal lobule and inferior parietal lobule, and these two are separated by the intraparietal sulcus. Okay, and this is another one of those sulci that are quite deep actually. You can kind of see a little bit here the parieto-occipital fissure that I was telling you is really not so visible laterally, but this is where it is, and if you can identify the notch here, you draw the pre-occipital notch and you draw your imaginary line connected to two, everything that is behind it is occipital. Yes?
All these gyri are symmetric, the other are exactly the same.
It's never fully symmetric, but you should be able to identify all of them, especially the main one. Yeah, and it's also interesting. There's a lot of variability, meaning that, for instance, some people, the precentral precentral sulcus is continuous. Some people actually discontinuous. You actually have two sections that are interrupted. Some people have, let's say, one single cingulate sulcus that I'll show you in the next slide, and some people have two. So I'm not sure if this variability also happen in the same individual across hemispheres. Definitely there is a lot of variability across people, and there is definitely some variability across hemispheres as well, though. Okay, I can tell you that. Okay, so actually let's look at the real brain. Central sulcus is here, and again I'll tell you how to identify it in a second. There's a way. This is the lateral sulcus, and once you identify these two, I think you can identify a lot of stuff. So just behind, well, so in this case, you know, the eyes are here, right? So the back of the brain here, so the frontal lobe is here, okay? So just behind the central sulcus you have the postcentral gyrus, just in front of it is the precentral gyrus, and then you have the superior, middle, and inferior frontal gyrus, and then you have the superior temporal gyrus, as well as the middle temporal gyrus, and the inferior temporal gyrus. Okay, so again they run this way. Here you can see the intraparietal fissure that would separate the superior and the inferior parietal lobules. Okay. So how do you identify the central sulcus? So there is actually a nice tip. So if you look, so identify first the superior frontal sulcus, which it's pretty easy to identify. Again, it's a sulcus running in this direction. Is the closest one to the interhemispheric fissure, so closest to the midline. Okay, that stops at the level of the precentral sulcus. Okay. And you know, this is the precentral gyrus here. If you know that, you know that this must be the central sulcus. Okay, so it's very easy this way. When you look at the MR images, you typically don't have this type of views, these 3D views. So you actually look at slices. A way to identify the central sulcus is to navigate until you actually see this omega shape. Okay, when you see this omega shape, some people for some reason have an epsilon. It has to be a Greek letter, but most people actually it's an omega, and when you identify that omega, you know that that's the central sulcus. And fun fact, actually, when you see the omega, that's the motor representation of or sensory representation of the hand. So if you're doing a finger tapping task in the fMRI scanner, and you want to see where the brain is activated, you should be able to see the omega contralateral to the hand is stimulated. Okay. So here, how you identify the central sulcus. Now let's look at, promise is almost finished. Let's look at the medial aspect of the brain. Again, this goes back to the Gray's Anatomy, and this would be the corpus callosum. Again, probably it's easier to. This is actually one of the easiest to identify in real images rather than this drawing, but this is what I have so far. Parallel to the corpus callosum, there is this big sulcus, okay, and this is the so-called cingulate sulcus, and the cingulate sulcus actually separate the corpus between the cingulate sulcus and the corpus callosum. You have this cingulate gyrus. Okay, you can see that the cingulate sulcus then curves up to a branch up to it's so-called the marginal sulcus, or the marginal branch of the cingulate sulcus, and basically this area here, which is delimited by this marginal sulcus, is the paracentral lobule. So the paracentral lobule is nothing but the postcentral and the precentral gyri. They actually meet in the medial aspect of the wall. So actually, if you remember this, let me just show you. Oops. Just go back to the image there. So they're separated here. The precentral and postcentral gyri is separated by the central sulcus, right? But in the medial aspect, they kind of meet. There's a nice little rendezvous there. And that happens to be the sensory motor representation of the leg. by the way. So if you remember your Neuroanatomy 101, where we're talking about Penfield's homunculus, the leg was actually located in the medial aspect of the wall. So this is the paracentral lobe. Okay, and then there are other functions, but this is one of the most common. Just in front of it is the superior frontal gyrus. Remember, I showed you the superior frontal gyrus on the lateral side. There is also a medial side of superior frontal gyrus. Some people, I've read somebody refer to this as the mesial frontal gyrus. I'm not sure if that's even English, but okay. So I showed you the paracentral lobule. This is the central sulcus. Just behind it is the precuneus. Okay, and the precuneus is the part of the brain is separated by, again, this marginal branch of the cingulate sulcus and the parieto-occipital fissure. You see, this is the fissure I was telling you before. It's very deep. You can actually see it mostly from the medial aspect. This is where it is. And this, together with this fissure, which is called the calcarine fissure, is mostly like an horizontally running fissure, which, by the way, happens to contain the primary visual cortex. These two regions together form kind of like a wedge. Sorry, these two sulci or fissures form like a wedge, and in fact this is called cuneus, which means wedge, and this is why this is called precuneus. Okay, so you can see how all the pieces kind of fall together after you start with one. It's like a domino effect. And then below the calcarine fissure on the bottom, you actually have the lingual gyrus. And then this image is actually a little bit confusing because it's as if this brain is a little bit tilted, because you're actually seeing structures that are mostly on the base of the brain. So it's kind of tilted, this brain. And so you start seeing the hippocampal gyrus, probably more appropriately called para-hippocampal gyrus, then fusiform, and you start seeing also the inferior temporal gyrus down here. But this is mostly at the base, so you have to make a little bit of an effort of imagination to understand that this is a little bit tilted. So I guess to make things a bit difficult, I actually show you the brain oriented a different way. That's okay. Cingulate gyrus. Oh, actually, I just noticed this. So this guy has not one but two cingulate gyri, sulci. See, this is something that was mentioned before. Yeah. And you can see how the cingulate gyrus actually surrounds the corpus callosum. This is the corpus callosum. Okay. This is very deep parieto-occipital fissure, and you can see. Oops. Just see. I don't see the. Okay. The calcarine fissure is here. And this is the wedge, that's why it's called cuneus. This part here would be precuneus, and down here is actually the lingual gyrus. And then at the base of the brain you'll find the parahippocampal gyrus, which is located just below the hippocampus, which I'll tell you in a second. So we talked before about the insula. So where's the insula? So the insula, in order for you to, so the insula is actually, it's called this way because it's an island of gray surrounded by an ocean of white matter. This is the poetry in Neuroanatomy, and you can see why it's called that way, because it's like a portion of the brain that will be swallowed by the overgrown cortex. So in order for you to see, to access it, you actually have to, so this is your lateral fissure, your Sylvian fissure. You have to pull the two banks of the fissure apart, and you actually start seeing the structure of the insula. Okay, this is where it is, and this is where it would be in an axial section. So hippocampus. I was telling you before about the hippocampus, and now you also see why I talked to you about the ventricular system. So how do you identify the hippocampus? So in order to find the hippocampus, you need to look below the inferior horn of the lateral ventricle. So the lateral ventricles, remember I told you before, there's this skewed C-shaped cavities, each of them located in an hemisphere. Okay, so they are skewed C-shaped. So this is a coronal cut. Okay, it's a coronal slice. So if we cut this finger this way, you start seeing the the finger, a section of the finger above and a section of the finger below, right? So this is actually what we're seeing here. There is the top and the bottom. So if you look at the bottom, okay, just below it, this is the inferior horn of the lateral ventricle. So the lateral ventricles are thought to have three horns. This is, again, is the anterior horn, this is the posterior horn, and this is the inferior horn. So what I'm telling you here is that you have to look for this inferior horn, which is here, and just below it, this is kind of a little bit pushed to the side, but just below the inferior horn of the lateral ventricle, that's where you find the hippocampus. And by the way, it's called hippocampus because it kind of looks like a seahorse. See? And here you can, there's been part of the hemisphere, quite a bit of the hemisphere removed, so that you actually can see how the hippocampus is contiguous to the fornix. Okay, and this was just to show you hippocampus becomes fornix here, and then it dives. If you remember what I was telling you before, it dives vertically to go and meet the mammillary bodies, and just in front of it is the anterior commissure. Okay, so this is a lot of material, but this is all, you guys have slides, and it's all recorded, so you can come back to it, and hopefully it's, even if you retain 5%, or it's gonna still be okay. Then you identify the hippocampus. When you identify the hippocampus, identifying the amygdala, it's easy. Okay, the amygdala is another important structure you probably will hear a lot about, and essentially it's just in front of the hippocampus. Very easy. So once you know what the hippocampus is, you see this is an almond-shaped structure located in the medial temporal lobe. Okay, and there's one again on each side. Hippocampus, amygdala. So I don't think do we have time to deal very quickly to the basal ganglia, or I think we want to leave some time for, maybe it's enough. All right.
2 more minutes.
2 more minutes, is that okay? Oh, okay, sounds good. So, okay, let me just, let's not go too much into the details, but just let me show you an axial section of the brain, and just to point out additional structures. So, we recognize this is the thalamus because these are two egg-shaped structures right in the center of the brain, okay? And there is more nuclei here. What are these? So, these are the basal ganglia, and there's a trick to identify the different structures. You can see there is kind of like an L shape. It's not super clear, but it's kind of like an L shape structure here, and this is the so-called internal capsule. So it's made of axons, so it's like fibers, and there is an anterior limb and there's a posterior limb. Once you identify this, you can actually identify a lot of structure, because the anterior limb separates this, which is the caudate nucleus, from this, which is the lentiform nucleus. Okay, and the lentiform nucleus is made up of the putamen, more laterally, darker, and more medially, this paler structure is called the globus pallidus. Pallidus means pale, so that it's kind of easy to understand. So this is when you identify the anterior limb, you are able to distinguish caudate from the lentiform nucleus. Okay, putamen, globus pallidus. The posterior limb separates the lentiform nucleus from the thalamus. So yeah, so I guess that's pretty much it. Yeah, perfect. So now you actually also have a clue to distinguish all this structure. And I think now it's test time. Let me see. Oh, this is what it looks like in a MRI. So you can kind of see, you know, this L, right? Anterior limb of the internal capsule, caudate, lentiform nucleus, putamen, lentiform nucleus, globus pallidus. This is the posterior limb of the internal capsule, and so this is the thalamus. And after its tour de force, I think it's test time. So let's see if I can actually show you again the video, and I'll ask you to try to see if you can identify the mistakes, okay? Let's see. How do I do it? 5. Uh-oh.
And now the parts of the brain performed by the brain.
Yes. Your cortex frontal lobe, hippocampus neural lobe, right hemisphere, content cortex visual, Sylvian fissure pineal, left hemisphere, cerebellum.
And this is why they invite me, yes. All right. So, what do you think? You guys have identified some mistakes, or anybody wants to give it a try? There is Dan, who's my postdoc. I hope he knows. Right. Okay, that's one. So the brainstem, when I say brainstem is actually the whole, brainstem plus the thalamus and okay, good, you got that one. Then there is the central fissure. I think it's actually an interhemispheric fissure. I think there is forebrain, and it's only the frontal lobe and included. Okay, perfect. You guys learned everything, so I guess I succeeded. Thank you so much.
Do we have any really quick questions before we adjourn?
Yes, I have a question. Is there any relation of these areas with the Broadman areas?
Oh, very good question. So, okay, so you were asking if there is a relationship between the anatomically defined, regions versus the cyto-architectonically defined regions using Broadman area. Not so much. So, for instance, if you think about the precentral gyrus contains area 4, which is the primary motor area, but only in the more dorsal aspect of it. So then the rest of it is actually buried into the sulcus. So yes and no, roughly, but not so much. This is scientific explanation at its best. All right, thank you so much.